Assalamualaikum and hi everyone. So in this video we'll be talking about the uses of analytical balance and volumetric glassware. So why do we need precise measurements? Well, in pharmaceutical lab, precise measurement is super important as it can affect the drug safety and also its quality. So you might be wondering, what is an analytical balance? This is an analytical balance. This right here is a highly sensitive laboratory instrument that can measure mass up to 0.0001 gram. We also have other types of analytical balance, which is this, and also this.
The first step is to open the draft shield carefully and put in our weighing board. After closing the draft shield, press the tab button to set the display to 0.000 gram. Next, using a spatula, slowly add the sample into our weighing board. Make sure to add small amounts to avoid overloading the weighing board. Finally, once the display stabilizes, we can record the mass.
Hi everyone, the next one is, what is volumetric glassware? Volumetric glassware is lab equipment for precise liquid, volume measurement and delivery. They are essential for accurate solution, preparation and analysis, such as beaker, volumetric flask and burette. But did you know volumetric glassware have two types? The first type is non-volumetric glassware. The second type is volumetric glassware. Let's reinterpret each type volumetric glassware. I start with non-volumetric glassware. I use beaker as example. Did you know beaker is most useful for chemical, biological and clinical lab? But beaker is practical, user-friendly, that great for preparing and holding solution. Beaker also useful for storing, mixing and transferring liquid, and beaker in categories to contain. Next, we move to second type, which is volumetric glassware. I use burette as my example. Burette designed with a long glass tube, graduated and stopcock at the end to regulate liquid flow. Did you know burette used in titration procedure for quantitative analysis in industrial chemical tests? And burette can accurately transport a solution and in categories to deliver. Based on all my explanation, did you ever think why we use volumetric glassware? The first one is to minimize measurement error to guarantee their measurement precise and reliable. The second one is chemical resistance and durability. Volumetric glassware can stand with high temperature and chemical attack because volumetric glassware made from polysilicate. This guarantee purity of substance can be safely stored with degrading. Lastly, we have reproducibility. Volumetric glassware is precision provided that experiment can be conducted again and again with reliable outcome.
Moving on to application in pharmaceutical, we choose preparation of paracetamol. What is paracetamol? Paracetamol is synthesized in pharmaceutical lab through the acylation of p-aminophenol using acetate anhydride. Here is all the apparatus and chemical reagent that we need to prepare before the experiment. Hot plate, distilled water, evaporating dish, spatula, filter paper, funnel, p-aminophenol, acetate anhydride, 100 ml beaker, 250 ml conical flask, 2 measuring cylinder, 10 ml and 50 ml, glass rod. Weighing p-aminophenol. Firstly, prepare weighing board, p-aminophenol and spatula. Open analytical balance door with care. Put empty weighing board on analytical balance pen. Close the door to prevent air current. Press the terra or 0 button. It set the display to 0.0000. Open the door carefully. Use a clean spatula to add p-aminophenol into the weighing board. Do not pour directly out of the balance pen. Close the door again before taking a reading. Wait until the reading is stable and then record the display. Step number 2, solution prep. Transfer weak p-aminophenol into 100 ml beaker. Using measuring cylinder, add distilled water. Carefully transfer distilled water into beaker containing p-aminophenol. Stir the solution using glass rod. A 10 ml measuring cylinder is used to measure and add acetic anhydride into solution. Then we stir again using glass rod until we get cloudy solution. Step number 3, crystallization. Turn on hot plate and set it to 60 Celsius. Allow it to preheat for 5 minutes. Once it's hot, carefully place the beaker on top of the hot plate. Monitor the solution closely during heating. Step number 4, filtration. We need to prepare distilled water, mix the solution, folded filter paper, funnel and conical flask. Firstly, place funnel on top of conical flask. Gently press the filter paper against the funnel wall so it fits perfectly. Wet the filter paper with small amount of distilled water to help it stay in place. The filtration should start immediately. Slowly pour the mixture into the funnel. Last step, drying. Place the precipitate on filter paper in evaporating dish. Transfer it into desiccator carefully. Seal the desiccator tightly and leave it for overnight to remove the moist completely. Then we will get a powder paracetamol.
Hello guys, today I'm going to say about something that a lot of people ignore but is super important. Do you guys know what it is? What? We don't know. It's about safety precaution when handling analytical balance and volumetric glassware. First, let's take a look at safety precaution when handling analytical balance. Make sure to clean the balance before and after use, such as remove dust, powder or any chemical residue. Avoid using the balance near windows or fans because air movement can disrupt the measurement. Please make sure to close their balance doors before taking a reading because even small air currents can affect the reading due to the high sensitivity of the device. Next, we move to the safety precaution when handling a volumetric glassware. Please always handle the glassware with care. Always rinse with the correct solution to prevent contamination and maintain the accuracy. Lastly, place glassware on flat and stable surface. Welcome to the lab, where one tiny mistake can turn your paracetamol into poison. No pressure. First up, the analytical balance. This machine is so sensitive, it basically has trust issue. Like, you just look at it too hard and the number changes. I swear, if I breathe too close, it's like weight error detected. So I stand still, hold my breath and pray to the science god that I get the exact weight, because if I'm even 0.01 gram off, boom! Next, we have the volumetric glassware. Sound fancy because it is. These things are not your average water bottle, okay? You mess up the volume and suddenly your 0.1 molar solution is giving 10 molar personality. One extra drop and the whole solution's like surprise! I'm too concentrated now. Love that for me. Moral of the story? In a pharmacy lab, we don't guess. We don't eyeball. We measure like our lives depend on it, because sometimes they kinda do. Anyway, if I survive this lab, I'm putting professional measurer of tiny things on my resume. Wish me luck!